Okay, welcome back. This is Mr. Hassan's Maths channel, and here is a question from the P3 Pure Mathematics P3 International A-Level Edexcel textbook. And this question is from chapter 8, which is all about numerical methods. And here we're talking about fixed point iteration. Is exercise 8b. Question number 3. And I was requested to answer this question by one of the viewers. In fact, this is one of those topics which is one of the easiest topics, but one of the least well understood topics. So people know exactly what to do, but they don't really understand the kind of logic or the procedure that's actually behind it. It's just like mechanically go through and get the marks for the question without really understanding what's going on. And most students in this particular topic would kind of like fulfill that kind of characteristic. They don't really understand what's going on, but they can get the marks because you're not really ever asked to explain anything in this particular part of the topic. But this question actually does ask you to explain a bit, and that's why many students have some issues with this. So the first thing is, it says f of x is equal to x squared minus 6x plus 1. Show that the equation f of x equals 0 can be written as x equals the square root of 6x minus 1. So first of all, we will put f of x equals 0, which means x squared minus 6x plus 1 equals 0. So what's happened is this equation has been rearranged to make one of these x's the subject of the formula. So it's quite obvious that the x that has been made the subject of the formula is the x which is squared, because in the end, when you want to make x a subject, you're going to have to square root it. So this x has been made the subject of the formula. That's quite obvious, right? So if we rearrange this to isolate this x squared term first by adding 6x and subtracting 1 from both sides, we're left with x squared equals 6x minus 1. And then we can take the square root of both sides to end up with x equals the square root of 6x minus 1. Now we're only going to consider the positive square root, and we'll explain why in a minute. Then it says sketch on the same axis the graphs of y equals x and y equals the square root of 6x minus 1. Okay, now y equals x is a straight line which passes through the origin, and it has a gradient of 1. We should all know that. That should be pretty well understood. So something like this, that would be y equals x. Okay, so it's like when x equals 1, y equals 1, when x equals 2, y equals 2, when x equals 0, y equals 0, and so on. So here would be the line y equals 1. Okay, let me try and make it a bit more kind of, yeah. Okay, so that's y equals x. Okay, so there we have the line y equals x. I'll just label it down here. And then we have to draw or sketch the graph of y equals the square root of 6x minus 1. How would we go about doing this? Well, what I would do is first I would say, okay, let's consider y equals the square root of x, which is the parent function. Okay, now how would that look? Well, the graph of y equals square root of x, if we only consider the positive square root of x, which we only need to do here, it will have this type of shape. That's y equals the square root of x. Okay, and that would pass through this point here, which is the point 1, 1. Okay, because when x equals 1, y equals 1. That's where this would pass through. That would be the point 1, 1. Okay, now that's where they would intercept at that point, because of course, with y equals x and x equals 1, y is 1 as well. So they'd intersect at that point. But here we have a couple of transformations that have taken place. Right now, you have the square root of 6x minus 1 is what we have to try to sketch. Now, when you have a transformation like this, okay, of the parent function, what's happened here is basically everything that's taking place is inside the function. You're not multiplying the whole function by anything. You're changing what's inside the function. The x has been replaced by 6x minus 1. Now, when it's inside the function that the changes take place, you must deal with them in the order which is opposite to BIDMAS, and it does make a difference. So we're going to first deal with the transformation caused by this minus 1, not the multiplication, the subtraction first. So this causes a translation, and when it's inside the function, remember it acts weird, of positive 1, 0. So it's 1 unit to the right. So this whole graph would move 1 unit to the right. So where they intersected here, that'd be 1, 1 here. This would move now to there. And that would be this graph. All right, that'd be the graph like this. And that's the first transformation. The second transformation is this is multiplied by 6 by inside the function. So this is a horizontal stretch. And when it's inside the function, it acts weird. So although it's multiplied by 6, the scale factor is going to be 1 over 6. So all the x coordinates, they are multiplied by 1/6. So this will go down to here, 1/6. And the whole graph will look kind of like a bit squashed up. So it'll be kind of something like this. So that's how the graph of y equals the square root of 6x minus 1 would look. It's just a rough sketch, but that's how we can make a sketch of it. Okay, using transformations of graphs. And we can confirm certain things. For example, we know that this cannot exist when this underneath here is negative. So 6x minus 1 must be greater than or equal to 0 for this to be defined. And we can see what happens when we rearrange this. We end up with x is greater than or equal to 1/6. As we can see, x must be greater than or equal to 1/6. Okay, so kind of fits in with our sketch. So the order matters when you are sketching these graphs. Okay, when it's inside the function, you do the opposite of BIDMAS. When it's outside the function, you do the same as BIDMAS. And the order does matter in many cases like this one. Right now, so that's part B done. And now for part C, it says write down the number of roots of f of x. So as we can see here, there are 2 roots. The roots are the places where, you know, f of x equals 0. Now this f of x equals 0, this is the same equation as this. It's just rearranged. So the number of roots of this equation is the same as the number of roots of this equation. And we can see that the number of roots of this equation is where these 2 sides intersect. And we can see they intersect in 2 places. Okay, these 2 places. So you can say, it just says write down, so we can put 2, but 2, if they say explain why, we can say there are 2 intersections. 2 intersections. Okay, now for part D, it says use your sketch to explain why the iterative formula xn plus 1 equals the square root of 6xn minus 1 converges to a root of f of x when x0 equals 2. Okay, so now basically what does this mean? It means you replace the x in this function with 2 and you see what value comes out, and then you replace the new value that you've got, okay, once you put x equals 2 in here, back into the same function, and you keep doing it until it converges to a particular value. Right? That's what we do. In our calculator, what we would have done in this question, if they didn't ask us to explain by the graph, we would basically start off by saying we're going to use x equals 2 first, so I'll put 2 equals. That's now the answer in my calculator. And I'll just set this up as the square root of 6 times answer, 6 times whatever answer, which is 2 right now, minus 1. And when I press equals, it will replace the place where it has answer with 2. Okay, then when I press, that will give me this value root 11. Now, when I press equals again, it's going to replace this answer with root 11. So whatever comes out of this when I put x equals 2 is going to now be put into the same function again, and that will give me another value. All right, and then when I press equals again, it's going to put this back into that place. It's going to keep doing this, and it's going to basically converge on a value. As you can see, it gets closer and closer to a particular value. The numbers settle down. All right, and you can kind of then write down what the root is, correct a certain number of decimal places. That's what we know how to do in this topic. What we don't really do much here is actually explain why. So basically what we're doing is we're first substituting x equals 2 into the function. All right, so I'm going to try and show this as best I can. I'll maybe zoom in a bit as much as I can. Okay, so when you put x equals 2 into this function, say that's x equals 2. It's going to come out with this value for y over here. When you put x equals 2 into this equation, it's going to come out over there. That's going to give you like root 11, as we can see. 6 times 2, 12 minus 1, root 11. So that's going to be the value now that this gives you. Now you're going to put that value back into the function. So that value, okay, is going to be the same value now here for x. Remember, this is y equals x. So whatever that value was here, that was root 11. That's going to be root 11 down here. That's going to be put back into the function. Okay, so it's going to give you another value up here somewhere. Okay, it's not very straight here. It's going to give you another value up here somewhere. That's going to be y equals whatever that was. Okay, and that value is going to be replaced back into this function. The x value put back in is going to be the same as that, you see? And that's going to give you another value, which is going to be up here. Okay, so sorry about that. Let me just make that smaller. And then you can see what's going to happen basically eventually is this thing is going to get closer and closer and closer to the root. It's going to give you a value closer and closer to the actual root. So when you put x equals 2, okay, into the function, it gives you a value up here. You're putting that value now back into the function. Okay, and then you're putting this new value, okay, which is over here, back into the function. And you keep doing this until it converges to a value close to the root. Okay, so it's basically converging. As you can see, it's getting closer and closer to the root. Okay, so we can say that, how would we explain this? Use your sketch to explain. We can draw this and we can show that, okay, each new value leads closer to the root, you could say. I suppose that would be closer to the intersection, therefore the root. Okay, so that would get you closer to that root, I guess. All right, and I guess if you choose a value less than 1/6, that might get you closer to this root. Okay. Anyway, now that basically explains that. I've put the explanation up here. Part E of this question. It says f of x equals 0 can also be arranged to form. Let me just come out of the zoom a bit. Okay, can also be arranged to form the iterative formula xn plus 1 equals xn squared plus 1 over 6. By sketching a diagram, explain why the iteration diverges when x0 equals 10. Okay, so obviously what they've done here, if they've made this x a subject, they didn't tell us to show how, but we can make this x a subject by, remember, we start off with saying x squared minus 6x plus 1 equals 0. If you make this x a subject, you have x squared plus 1 is equal to 6x. So x squared plus 1 over 6 equals x. So by making this x a subject, you end up with this iterative formula. Okay, now, they're saying here, by sketching a diagram, explain why the iteration diverges when x0 equals 10. So we got to draw the graph of y equals x squared plus 1 over 6. If I rewrite this slightly so it's a bit easier for us to deal with, a half x squared plus 1/6. So we can see that this is going to be a graph which is going to pass very close to the origin. Okay, over here 1/6 is that's gonna be its vertex. It's one of these quadratic graphs. Okay, it's going to open upwards, and it's going to look something like this. Not very. It's all right, I guess, for a sketch. So that's y equals a half x squared plus 1/6 x squared. So 1/2. Sorry, 1/6 x squared plus 1/6. Not a half. Okay, 1/6 x squared plus 1/6. Where did the half come from? I don't know. Yeah, so this is like y equals x squared, and it's shifted one space upwards, and also it has a scale factor of 1/6 vertically. So it's going to be a bit narrower than normal, but this is not to scale, so no problem. All right, so it's going to look something like this. But let me just draw it again so it's a bit more clear. So want to just make it a bit clearer. Okay, this is y equals x already drawn. So now I'm going to draw this a bit. So it's going to go through 1/6. And also this is really not to scale. Okay, so that's 1/6. I'll just move that up a bit. Okay. Not such a good graph, but still. Now, in this case, if we say x equals 10 is over here somewhere, if we substitute x equals 10 into this, okay, I'm going to have to extend this so that it makes it a bit clearer. Okay, if I substitute x equals 10 into this, what happens is the following. As you can see here, what will happen is it's going to give me a value which is up here somewhere. Let me move the 10 a bit to make it clearer. Just say the 10 is over here. Okay, what's going to happen is going to give me a value up here somewhere. Okay, it's going to give you a value all the way up here, which is going to be this value here. So this value, whatever came out here, is going to be now put back into the equation. Okay, and then what's going to happen, as you can see here, it's just going to basically, I'm just going to draw this a bit further up. It's basically just going to diverge away, because the next time you put the value in, okay, the next time you put the value in, what's going to happen is it's going to give you a value up here somewhere. And then if you put that in, it's going to give you, it's going to get further and further away. It's not going to go towards the root, it's going to go away from the root. So any value which is on this side of the intersection will go towards the root, okay, because that will give you a value here, which will then be put into the equation, okay, and then when it goes back in, it's going to go like this, basically. It's going to end up towards this root. But on that side, it's going to go away from the root. It's going to go away from this particular root. Okay, so it's going to diverge. So by sketching the diagram, explain why the iteration diverges when x0 equals 10. So we can say when x0 equals 10, okay, we can say intersections move away from the root or the roots. Okay, you could say the values, the output values. That's how I would word it. What did I write here? Each new value, you can say each new value. That'd be better, I guess. Each new value moves away from the roots. Okay, so you can see that it diverges. It doesn't go towards it. In this case, what happened? Okay, you can see that the new value takes you there, and then that value takes you there, and then that value is gonna go towards the root. But when you're on this side, okay, you're gonna, like, for example, in this particular case, the same thing would happen. That would also diverge. Okay, so if you were to confirm that, supposing I use this iterative formula, okay, with x0 equals 10. So in this case, I'd put 10 and then answer. Oops. 10 equals, sorry. 10 and then equals. And then I would use this as answer squared plus 1 over 6. Oops. Plus 1 over 6. Then I press equals. It gives me this value. Press equals again. Equals again, equals again. It just completely gets bigger and bigger and diverges away until it gets so big that it gives you a math error, right? So it doesn't kind of go towards a particular value. It goes away from the root. Okay, so that's part E of this question. I hope that was clear. As I said, they don't really expect you or ask you to explain this kind of concept in the exam. This is just maybe some extra kind of understanding that they want to give you in this particular exercise. But it's good to know what we're doing always. All right, I've never seen a question where they ask you to explain this, but it does help you to understand what the process of iteration actually is and how it works. So I hope that was clear. I hope I explained it to your satisfaction, and inshallah, I hope that you can understand it properly. Thank you for watching, and other questions from this particular chapter, if I am asked to answer them, will be in the playlist that will appear in this region over here. Other questions from the P3 topic of numerical methods in general, questions from past papers or wherever, can be found in the playlist over here. You can subscribe to my channel by clicking on this link. You can watch the video here, which will tell you how to use my channel to find what you need efficiently. Thank you for watching, and see you soon.